This video shows the process of configuring your AlphaPix pixel controller. This particular pixel controller is the AlphaPix 4, and we are running the newest version of the firmware currently available at 2.08. If your interface appears to be different, please go to our website, holidayquarrel.com/firmware. That's FIRMWARE. And you can receive an updated copy of the firmware and instructions for installing that. In this particular case, we are going to be using Google Chrome. We do recommend Google Chrome as opposed to certain other browsers which have known to have issues. This configuration video will show you all the settings within the AlphaPix and how to configure them. Now, if your controller has a login screen, note that the password is 12345. Newer versions of firmware do not require the password to be entered on startup. Let's start. The first thing we have here is the indication as to the type of controller. An AlphaPix 4 is shown here as a 4-port Ethernet to SPI controller. We see the IP address of the controller. Each controller will have a unique IP address. So, for example, if you had one controller at 192.168.0.50, your next controller may be 192.168.0.51. This may vary depending upon your local network. If you're using DHCP or dynamically assigned IP addresses, which we generally do not recommend, this number may be different. Under the About section, we have the device ID, including the unique serial number. You can name your controller to have a unique name. This may be useful, for example, like Megatree or Arches or Left House Outline. For password, if you do not need a password and your network is secure, we do not recommend entering a password. You can enter your current password, which is 12345, and set a new password. This will require the password every time you start the interface for this pixel controller. The next item we have is IP address assignment method. There are two basic ways to assign IP addresses. Either one, DHCP. In most typical houses or businesses, there will be a server or a router or other device that provides an IP address for each device that connects to that network. This is commonly your DSL modem, your cable modem, your Linksys, or other type of box. Now, we generally do not recommend DHCP. Why? It's because this address can change. While it may be consistent for a couple of days, if you unplug the controller and plug it in a couple of days or weeks later, another device may have used that IP address, and then your sequences which are configured for that IP address will no longer work. So, we recommend, and the default is a static address. Now, we are using our static IP address of 192.168.0.50 and a subnet address of 255.255.255.0. That is because this IP address and subnet indicate that just the last digit, or what's called the last octet, the fourth section of the IP address, can change. Now, again, as I mentioned before, you will need to change multiple controllers to different IP addresses. You may wish to change this IP address to a new number, for example, 1, like 51, 52, 53, so that if you do bring a new controller on the network, it will always default as 50. Now, if you have an existing controller on the network and you bring a second controller on the network with the exact same IP address, both controllers will no longer respond. Whenever making a change, you need to update IP address information by clicking this button. The next item we have is Ethernet protocol. This controller can work with either E131 or streaming ACN or ArtNet. Streaming ACN or E131 is typically used in holiday lighting applications, such as applications as LOR S4, S5, or X-Lights, Vixen, or other applications. If you're using applications such as Madrix, make sure to select ArtNet. Most DJ and other third-party lighting applications typically will use ArtNet. These protocols are basically the same, with ArtNet being an older version of E131. Whenever you make a change to the setting, click Set. The next option here is Color Output Order from Application. Now, we should note that this does not affect the type of pixels that you have connected to the controller. In almost all cases, you're going to leave it at RGB. What this setting means is that it is assuming that your application thinks that the controller is using red, green, blue as the color order. And in almost all cases, most applications for holiday sequencing assume that red, green, blue is the order. Unless you're absolutely sure, leave RGB as the selected type. The next option we have is the SPI Output configuration. Now again, in this case, we are using a 4 output unit as opposed to a 16 output unit. Now, this is not typically the way the controller would come configured. You will need to configure it based upon your specific settings. For example, you may see that the universes skip. This has to do with the particular settings and design of the controller. For an AlphaPix 16, there are 2 universes. A universe is a collection of up to 512 individual channels. So if we back that down further, a single pixel is 3 channels, or 3 DMX channels. That's, for example, red, green, and blue, and those comprise 1 pixel. So that means if we have 3 DMX channels per pixel, that means there could be up to 170, which is 170 times 3 is 510, out of the total 512 possible pixels in a universe. Now, it is possible on the AlphaPix 16 to connect 2 universes of pixels, or 340 pixels. That means that when it uses up the pixels from the first, or the DMX addresses from the first universe, the second universe will be automatically used, which is why you may see your controller come with an address skipped for that universe. So, if you are not using more than 170 pixels on any output, you can have sequential numbers. So, for example, here, I can put in 1, 2, 3, 4, as long as I don't have more than 170 pixels configured. You want to configure the number of pixels in this column, the third column, to be the actual number of pixels you have connected. This will improve the efficiency of the controller. If you have 50 pixels connected, such as a typical pixel megatree of 50 pixels, enter 50. If you have more than 170, enter that number. If you're unsure how the concept of DMX universes and how multiple universes can exist in a single output, see our AlphaPix configuration page at holidaycoral.com/AlphaPix. Let's go over each one of these settings. This is the DMX start universe. What will happen is you'll define the first universe to start from, and then all the pixels after that will then sequentially increase. This is the DMX start channel address. So it is possible to start your DMX universe at an address that is not one of the 512 channels. We generally recommend, in most cases, and for most people's configurations, start at 1. Now here we need to enter the number of pixels. Again, if this number is over 170, you're going to be using more than 1 universe. Null pixels are pixels that exist solely to repeat data. For example, if you have a long distance, say over 20 or 25 feet, you may need to insert a null pixel. So if you had 10 pixels connected to a string of pixels, and then you had 1 null pixel, you would configure 50 pixels for the total number of pixels, and then 1 null pixel. That first pixel will just not count. It will only serve the purpose of repeating data to extend the distance to reach the extra pixels. Zigzag addressing allows you to reverse the addressing for matrix setups. What this means is that after you reach a set number of pixels, for example, let's say that we have 100 pixels configured and we have the address set at 50. After the 51st, it will reverse and start over again. Limit intensity allows you to dull down pixels that may be too bright. Sometimes you may mix different types of pixels, and some pixels may be brighter than other pixels, and you may wish to even them out so that they all appear to be the same. This allows you to do that. So leave your brightest pixels at 100 and then reduce any others that need to be reduced. Reverse addressing allows you to reverse the addresses used in pixels. For example, normally the first pixel connected to the output that does not have a null pixel configured will be DMX address 123. That would be red, green, blue, for example. But let's say that you have 50 pixels and you wish to reverse the addressing so that the first pixel is actually the last pixel. So if we had 50 pixels, it would be 50 pixels times 3 DMX channels, which shows a total of 150 DMX channels. We can make the channels go 150, 149, 148 by selecting a reverse addressing. So basically, this just makes the last pixels in your string the first pixels in your string from a logical addressing and DMX addressing standpoint. This is typically used in house outlines. Now, again, you can configure each one of these. DMX universes can overlap. If you overlap them, the data will do the exact same thing for each universe. So if I configured 100 pixels on the first output and 100 pixels on the second output, but had the same DMX start universe, they will do the same thing. Normally, you wish them to do different things, and you will need to select an appropriate DMX universe. Again, remember, if you use more than 170 pixels, you will need to use an additional number above that. Again, if we had 100 and, let's say, 80 pixels, we would need to make this next universe 3, and then so on. Whenever you're finished making your updating for this section, click Update Pixel Output Settings. The next setting we have is the E111 or RS45 DMX 512 output. You may notice that on your controller you have either 1 or 3 outputs. For the AlphaPix 16, there are 3 outputs for running legacy DMX controllers that use the E111 or RS45 based protocol. This allows you to hook up 27, 30 channel, 3-channel DMX dumb controllers and other devices such as our AlphaPix. See our other videos on how to properly configure this. When enabled, make sure that you click Set. Normally, this is not necessary to be enabled. The next option is very important. This is the Pixel protocol. By default, our controllers come configured with 2811. All Holiday Coro pixels are 2811. The Pixel protocol is the language that your pixels use. Typical methods or types are 2811, 2801, 6803, 3001, or 2812. If you have a protocol or non-Holiday Coro pixel, select the appropriate protocol necessary from this list. Make sure to hit Set whenever you're done. The next order is Pixel Chip Output Order or Color Order. Not all pixels are actually physically in red, green, blue. That means that the logical addressing, for example, let's just say if we started with DMX address 1, it might be DMX address 1 for red, DMX address 2 for green, and blue is DMX address 3. But that is not always the case. And in fact, it's not always common for that to be the case. It is possible that your pixels use a different order, such as BRG. If your pixels use a different color, or whenever you're using the hardware test mode and your pixels do not say the same color as what's shown on the LCD test display in your AlphaPix, you may need to change this setting appropriately. Now, this setting is a set based upon the entire controller. This assumes that you're using the same type of pixels for all the pixels on the controller. If you are using a controller with multiple different types of outputs, you can set them each to their own unique color order. So again, this is typically only if you're using pixels that are different for each individual output. Make sure, of course, to hit set when you're finished setting that setting. The backlight is useful for configuring the brightness of the LCD. The LCD is on your LCD interface of the AlphaPix controller, and the backlight is how bright the light is going to appear when you're viewing it. You may wish to darken this because in nighttime conditions, highest levels of brightness may be too bright for your particular case. Or you may be using them in a theater or other application in which you wish to have them dulled down. The next option shows configurable and non-configurable information. This involves the voltage, temperature, and shutdown. Please note that this version of the controller is the version 2 or 3 or greater. Version 1 controllers do not have this functionality. This shows the voltage. Now we should note that this is an approximate. It is not absolutely correct. If you're trying to get absolutely correct, we do recommend using a multimeter, but this helps ensure that you have the proper voltage. Of course, the power running into the controller typically is the voltage used by the pixels. In this particular case, we can see the common 12 volts being the voltage. We do recommend this amount being exactly 12 where possible. You may have an adjustment on your power supply to adjust the voltage to tune it exactly right. Note that that voltage will change based upon the demand of the lights. So if you have a lot of lights connected and they're all on, it's possible this number could drop as low as 9 volts, for example, in a 12 volt situation. The next setting we have, or output data, is the board temperature. In this particular case, we can see that the board is running at 82 degrees Fahrenheit. That is normal. The chips on the board will heat the board. This is perfectly safe. Now, what we can do is if you're mounting this controller into an enclosure for safety, you may wish to have configured this output shutdown. What happens is that when the controller reaches this temperature, in this particular case 135 degrees Fahrenheit or 57 degrees Celsius, the controller will continue to operate, but the output to the pixels will turn off, preventing any additional heat from being generated by the power going through the controller. This is adjustable to the setting that you wish. Note that the temperature should be set no higher than any combustible materials that are within that area. So if your material that you're using to mount the controller to, or the enclosure, or any other factor might be warmer than this, set that to below that temperature. Whenever you're done making the change, click Update Settings. Note that the temperature and voltage can also be seen on the LCD setting. On version 2 and 3 and above controllers, we do have a fan temperature trigger. The fan temperature trigger is allowing you to control a fan from the controller. The controller has either a standard screw terminal on the side with 2 ports for a powered fan, or you'll see that there is a 3-pin connector for a typical CPU style fan. Those fans will just plug directly into the controller. Note that a fan is not typically required, especially when used with the controller output shutdown temperature. What this allows is that it will turn on the fan only when it receives a heat level input above the level indicated here. We do recommend not turning it on excessively because pulling air in via a fan will typically bring in snow, moisture, dust, bugs, or other items through a fan. And in most cases, a fan is not required for an installation. This is an advanced feature. The last option is firmware update. You can click this link to go to the firmware update site, which is holidaycoro.com/firmware, and this will allow you to download all the current firmware for our controller devices, including the AlphaPix. Be sure to download the firmware before clicking the update button. The update process is shown here, along with all the different versions of firmware and the changes that have been made. Note that your controller version may require a specific version of firmware. Be sure to look closely at the page for which version of the controller you have. When you're ready, click the Download button located at the bottom of the screen. This video concludes the setup instructions for the AlphaPix controller line web interface.